What if the universe is not a solid stage, but a performance engine? What if reality does not fully decide what it is until something tries to look? And what if one of the most famous experiments in science doesn't just reveal weird particles, but hints that the universe behaves like a system, saving processing power until observation forces an outcome? Tonight, we go straight into the heart of that idea. Not with internet myth, not with cheap philosophy, not with a guy named Trevor on a podcast saying, "Bro, what if we're in a computer?" No, we go with a legitimate physics experiment, one so strange that generations of scientists have stared at it like detectives at a crime scene where the chalk outline moved. This is the story of the double-slit experiment, and if you follow the trail carefully, you will understand why some people walk away whispering, either reality is deeper than common sense, or the universe is doing something that looks eerily like rendering. Imagine you are in a dark lab. In front of you is a barrier with two narrow slits. Behind it is a screen. Now take something tiny, light, electrons, even larger quantum objects in some versions, and fire them toward those slits. If those particles were just tiny bullets, you would expect two bright bands on the screen behind the two openings. Very normal, very respectable, very I paid my taxes and believe in cause and effect. But that is not what happens. What appears on the screen is an interference pattern, many bright and dark bands, exactly what you expect from waves overlapping. In single particle versions, the detections arrive one by one, yet over time they build that wave-like pattern anyway. Let that sink in. The particle seems to behave as if it went through both slits and interfered with itself. Already, reality is acting like it missed a software patch. Now the scientists ask the obvious question. Which slit did it actually go through? A perfectly fair question, a civilized question, a question wearing a lab coat and holding a clipboard. So they place a detector at the slits to find out. And the moment they do that, the interference pattern disappears. Gone. Now the result looks like particles going through one slit or the other, not a wave through both. The core trade-off between interference visibility and path information is a standard quantum result explored in many modern analyses and experiments. That is the moment the universe starts acting like a suspicious video game, because it seems as if reality says, "Oh, you want path details? Fine, then I can't also give you the wave pattern." It is as though the world refuses to generate both sets of information at once. And this is where simulation theory fans leap out of the bushes yelling, "Optimization, procedural rendering, lazy evaluation." Now hold on. Physics itself does not say we live in a computer, but this experiment does show that quantum systems do not behave like tiny classical objects with pre-written trajectories in the everyday sense. That much is real. If you had to design a simulated universe, one efficient strategy would be simple. Do not compute every detail at full resolution all the time. Only lock in certain properties when an interaction requires them. That is not a proven description of the universe, but it is exactly why the double-slit experiment has become catnip for the simulated reality crowd, because the system appears to behave differently depending on what kind of information is physically accessible. When no which path information is available, you get a wave-like interference pattern. When which path information becomes available, you get particle-like outcomes. Reality, at minimum, is not handing you a neat little classical movie reel where every object had one definite path all along in the familiar sense. Bell test experiments are especially important here. They show that a large class of local realist models cannot reproduce quantum correlations. And now the rabbit hole opens. Physicist John Wheeler pushed the mystery even further with the delayed choice experiment. This is where the setup is arranged so that the decision about how to measure the quantum system is made after the particle has already entered the apparatus. That sounds illegal. It sounds like the kind of thing causality would sue you for. And yet delayed choice experiments have been proposed and realized in forms showing that whether the setup reveals wave-like interference or path-like information depends on the final measurement context, even when that context is chosen late in the process. The point is not that the future literally changes the past in a simple sci-fi sense, but that classical stories about a particle having already decided what it was doing can fail badly. That is a terrifying sentence for common sense, because common sense wants this. The particle knew what it did, then we came along and checked. Quantum mechanics replies, that story may not be available to you. This is where simulation arguments get their dramatic fuel, because delayed choice makes reality look less like a pre-recorded film and more like a system whose final visible behavior depends on the measurement framework that becomes physically relevant. Again, not proof of a simulation, but absolutely enough to make your uncle at Thanksgiving hold his fork in midair and say, "So, the universe has patch notes?" Now let's leave weird and walk into weaponized weird. Some people tried to rescue ordinary intuition with hidden variables. Maybe particles really do have definite properties all along, and quantum mechanics is just incomplete. That would be comforting. That would be tidy. That would allow reality to keep its driver's license. Then came John Bell.
Bell derived inequalities that any theory based on certain classical style assumptions, especially local realism, must obey. Real experiments have repeatedly violated Bell inequalities, and the 2022 Nobel Prize in Physics recognized foundational experiments establishing this. In plain English, nature does not fit a broad class of models where properties are locally preset in the ordinary intuitive way. This does not mean faster than light messaging. It does not mean you can text Mars with your thoughts, but it does mean the universe resists being explained as a simple collection of tiny separate objects carrying hidden classical answers in their pockets. Bell is where the room gets quiet, because now it's not just that quantum mechanics is strange, it's that nature itself refuses to behave according to some of our deepest intuitive assumptions about separateness, locality, and pre-existing definite values. And that is why the simulation hypothesis gets invited back to the party. If reality is not fundamentally classical, if outcomes are not just sitting there waiting like unopened mail, if measurement context matters more deeply than we ever imagined, then some people ask, are we looking at physics or at the interface layer of a deeper information system? This is where I need to slam the brakes for intellectual honesty. The double-slit experiment does not prove we live in a simulation. Bell tests do not prove it. Delayed choice does not prove it. Quantum eraser experiments do not prove it. What they prove is narrower, and in some ways even more profound. Reality is not obligated to match classical intuition. Quantum phenomena are exquisitely real, experimentally robust, and mathematically predictive. But the leap from quantum mechanics is strange to therefore we are in a computer simulation is a philosophical interpretation, not an experimental result. That distinction matters, because if you erase that distinction, you are no longer doing science. You are just putting a lab coat on a ghost story, and we are not doing ghost stories. We are doing the far more dangerous thing, real science. Because the resemblance is haunting. Think about what these experiments seem to suggest. Some physical properties are not meaningfully available in the way classical thinking expects. Measurement setup changes what kind of outcome can exist. The universe seems to respect information constraints with eerie discipline. Nature does not appear to maintain a simple classical storyboard underneath everything. To a philosopher of information, or a computer scientist with insomnia, that starts sounding less like billiard balls and more like state updates in an information processing system. Not proof, but resemblance, and resemblance is enough to ignite the human imagination. We are pattern hunters, meaning makers, apes who discovered quasars and then immediately turned them into podcast thumbnails. Of course, we see the double-slit experiment and think, this world is being rendered. The real question is not whether that guess is emotionally satisfying. The real question is whether it adds explanatory power beyond standard quantum theory. Right now, the answer is, not scientifically, not yet. But let's go one level deeper. Maybe the simulation idea is clumsy language for something more serious. Maybe the real lesson is not we live in a computer, but that information may be more fundamental than the solid objects of everyday experience. That possibility is taken seriously in multiple corners of modern physics and philosophy of physics, though not as a settled conclusion. Bell experiments and quantum interference do not tell us pixels unto reality, but they do strongly suggest that naive classical pictures are incomplete. So perhaps the universe is not a simulation in the sci-fi sense. Perhaps it is something stranger, a lawful informational structure from which matter, space, and even our common sense idea of events emerge, which is both less Hollywood and much, much more unsettling. Because if that is true, then what we call the physical world may be less like bedrock and more like the visible output of rules deeper than ordinary perception. In other words, reality may not be fake, but it may be far less literal than it feels. So, what is the legitimate science experiment that can be used to argue for a simulated reality? It's the double-slit experiment, especially when connected to the broader family of quantum measurement experiments, which path detection, delayed choice, and Bell test violations. Not because they prove a cosmic computer, but because they reveal a universe that does not behave like a fixed classical stage set, a universe where what can be known, what can be measured, and what can meaningfully be said to have happened are intertwined more deeply than human intuition was built to handle. And once you see that, the simulation hypothesis stops sounding like pure nonsense and starts sounding like one possible metaphor, a metaphor trying, awkwardly, to describe a world that quantum mechanics has already warned us is stranger than our oldest instincts can tolerate. So, do we live in a simulation? Science has not demonstrated that, but science has demonstrated that reality is weird enough to make the question impossible to laugh off casually. The double-slit experiment is not evidence that the universe is fake. It is evidence that the universe is under no obligation to be simple, classical, or intuitively there in the way your brain expects. And honestly, that may be even more mind-blowing, because maybe the truth is not that reality is a simulation. Maybe the truth is that reality is real, just not in the shallow way we were taught to imagine. And that is a much scarier story. If this bent your mind even slightly, drop "render" in the comments. And if you want the next chapter, I'll do the follow-up, the Bell test, the experiment that broke common sense.